Abstraction is the essence of intelligence and the hard part of the problems being solved. I read that quote from Rodney Brooks in a book called Abstraction in Artificial Intelligence and Complex Systems. I was interested in that book because, as a software engineer and machine learning enthusiast, I noticed a lot of inconsistent beliefs about what abstraction is, and yet its essential concept in both fields. That book really clarified some things for me, and now I notice even more misunderstandings. In this video, I'll explain 8 common misunderstandings. First, we need to understand the basic definition of abstraction. To abstract means to draw from. So you take something and you draw out a subset of it. An abstraction is what you create through that process. So let's say you're styling a contact form. You specify the color of the submit button with a hex value, like #0052cc. That is a concrete value. You look at it and know exactly what color it is. But your contact form isn't the only button with that color. It's much easier for you to deal with a CSS class called blue. If all those buttons need to change color, you only need to change it in one place. And it's actually easier to read the code now. But your current color scheme isn't the only one that could exist. Users could choose, or your designs could change. So you create another CSS class called Primary to encompass all the possible colors that could meet the need of what that button was supposed to represent. Now, when you look at your code, it speaks back to you even more at the level you understand. As a programmer, you don't care that it's blue, just that it's the button that performs the primary action. In both of these steps, you created an abstraction. Hex colors have 16 to the 6th possible values. You reduced information when you created the CSS class. Now your button just says it's blue as opposed to only 30 or so other colors. So you abstracted, you reduced information, and it became something more familiar to you, not less. You abstracted into something less abstract. So this brings up the first 3 misunderstandings that are really common. The first is that abstractions hinder understanding. We just saw an example where an abstraction helped us understand the code better. The second is that abstractions are abstract. There are actually 2 different definitions of abstract that are important. One is used in a subjective way. That seems abstract to me. It's something we're unfamiliar with. It could be like a math textbook, or if an alien race visited us, their language would seem abstract to us. The opposite of this definition of abstract is concrete or familiar. The second definition is things that are objectively more abstract or pure. The opposite of this is specific, localized, or instantiated. Okay, the third misunderstanding is that there is a single spectrum of abstraction. You can create abstractions in many different ways. There are many subsets of potential abstractions. So it's not a spectrum. There are spectra of abstractions. When people talk about a spectrum of abstraction, they're usually confusing the 2 definitions of abstract, where there's a trade-off. The more abstract you go, the harder it is to understand. If you're abstracting in the wrong direction, this is true. But if your abstraction represents something more real or reliable than the concrete value, then the abstraction makes it easier to understand. So abstractions aren't bad, bad abstractions are bad. And this misunderstanding causes the next misunderstanding, that abstractions are powerful but not useful, and things that are concrete are useful but not powerful. We saw that our abstraction is powerful because when we change our code in one place, it affects all the buttons. That's powerful. But we also saw how useful it was. How much more productive can you be when you can type button btn primary instead of style equals #0052cc? It's hard to remember the hex value, so it's both concrete and not as useful. When we create abstractions that more closely resemble the way we think of things, we get abstractions that are both powerful and useful. So that's the 4th misunderstanding, that abstractions are powerful and not useful, and that there is a spectrum where the more abstract you go, the more useless it becomes, and you're trading off utility for power. Semantic HTML is another good example. Rather than seeing a ton of divs, we can finally look at our HTML files and immediately know what's what. If you look at the designs or the desired outcome, and you describe it in the most natural way, that is how your code should look. The best abstractions are stable over time because they represent reality. When I'm coming up with an abstraction, the best way I know that I'm creating a good abstraction and not a bad one is if I can name it well. Because if it's a real concept, chances are it's going to have a very good name. If I'm making an abstraction that only makes sense because of the peculiar way I'm coding something rather than because it more represents reality, I'm going to really struggle to come up with a good name. So this is related to the next misunderstanding. That is that premature abstraction is bad and dry isn't very important. I would say it doesn't matter when you make an abstraction. Once you realize that there's something real there, go ahead and make the abstraction. If you can come up with a good name for an abstraction, go ahead and make it now. Every time you see code that's repeated, you should look for something real, a real concept underneath that isn't being explicitly named, and then you should try to name it. And you'll notice that as we name things, our code becomes less chaotic and more orderly. It gets much easier to understand and change. Okay, now notice how this code changes visually as I create abstractions. If you were to ask a non-programmer which of these is more beautiful, what do you think they would say? The one on the left, right? Okay, as a software engineer, which one would you say is better? Obviously the one on the right. As humans, we love seeing patterns. Our brains get really excited when we see them. Patterns hint of the existence of something behind the scenes that's generating stuff. That means there's something that has power or influence, and it makes sense that we would be attracted to that, to try to understand it and maybe use it for ourselves. Jürgen Schmidhuber has an interesting theory about why humans find certain things beautiful. He says it's all down to compressibility. Our brains are natural information compressors. When we see something that can be compressed, we find that beautiful. A lot more can be said about this, but basically, it takes time when someone learns software engineering to override the basic instinct to want to see beauty in the stuff that we create. But after years of experience, developers begin to see repeated code not as beautiful, but as hard work. So this is why there should be almost no beauty in your source code. Paul Graham recently tweeted this. Patterns in source code are a bad sign, not a good one. A lot of people disagreed with him on that, but that's probably because they're not too experienced. But it's the same thing as saying that code should be dry. All right, that's the sixth misunderstanding, that source code should be beautiful. It shouldn't be. The seventh one is that abstractions lead to worse performance. This is a concern that I had when I was first learning programming. Everyone recommends making functions and calling them from everywhere and splitting codes into multiple files, and with all this stuff, doesn't it decrease performance? First of all, code reuse leads to more concise code. Technically, inline code is more performant when it executes. It's insignificant if it's taking the user's browser 10 seconds to download it and parse it. The overhead that these abstractions cause are extremely minimal. They're negligible. Secondly, good abstractions make humans more productive. That's important because if we have good abstractions, then we can understand the big picture. We can stay oriented in the code base, so when anything is suboptimal, we can find it more quickly. This allows us to focus on bottlenecks instead of just prematurely optimizing everything. If humans can understand what's going on the application-wide scope, then they can make the optimizations that matter application-wide. Good abstractions mirror the way humans see things. And the reason for that is because our minds are completely composed of abstractions, from top to bottom. So if we go back to the original definition of abstraction, it says that to abstract means to draw away from. This is exactly what neurons do, and neurons are what our brains are made of. Each neuron connects to a subset of the information available to it. When a neuron's connections are activated, it activates. So, each neuron is a filter, or a pattern recognizer. A neuron is literally an abstraction. We have artificial neural networks that emulate the function of human neurons, and they converge to the exact same abstractions that human neurons do. So I think it's only a matter of time before all human neurons are approximated by artificial neurons. So whenever somebody says that neural networks are limited in some fundamental way, it's just because they don't know yet how those artificial neurons are going to approximate the human neurons. But we will figure it out. It's only a matter of time. And that's the last misunderstanding I wanted to talk about. When people say that artificial neural networks will never achieve the things humans achieve, it's because they don't understand that everything humans do depends on abstractions. And abstractions are the exact thing that artificial neural networks are made of. There's a lot more to say about this, but it really deserves a video of its own. Specifically, there's one limitation people always mention, and that's extrapolation. They say that neural networks can't extrapolate, but they definitely can. I'll make a video in the future explaining why they're wrong. So subscribe if you'd like to hear my thoughts on that when I am able to make that video. Anyway, thanks for watching. Please share your thoughts in the comments and go and create some good abstractions.